It's everywhere, from the ends of the Earth to the equator and points in between. We're talking about water. Oceans make up 71% of the Earth's surface. And that's not including rivers, streams, and lakes. Combine it with the other thing we've got a lot of, sunlight, and a group of high school students say you've got the solution to a big problem.
The problem is simple. The problem is that fossil fuels are running out. Even if it's not a problem in 2 years, it's going to be a problem in 10 years, it's going to be a problem in 20 years. In 30 years, it's going to be a big problem.
Shantanu Joshi, Prag Batra, and Jay Reddy are members of the Harker School's Invention Team in San Jose, California. It's a group of budding engineers that believes there's a better way to get our energy. And it's with something they've invented.
Our device is an aquatic thermoelectric generator. What that really means is essentially floating on the water, similar to a boat or a buoy.
The device uses reflective panels to harness the sun's energy, but not like you might think. Team advisor Anthony Silk explains.
Like a solar power generator, this works in a similar fashion, except it doesn't get its energy from light, it gets its energy from heat.
The key idea of this project is how to generate electricity from the sun in an alternative way than photovoltaics, which are used right now.
Solar PV panels you see on rooftops convert sunlight into electricity, but that's not what's happening here.
This will be sitting on a body of water which will be cool, and so the difference between the hot panel heated by the sun and the cold water, that difference is going to cause an electric current to be formed.
The heat gets channeled down through our device, through these aluminum squares, and then into one of these thermoelectric panels. As it goes through the panel, then it goes back out through an aluminum square and through the sheet metal on the bottom of our device and gets dissipated into the water.
As you can imagine, invention isn't easy, both from a design standpoint and a dollars and cents one too. But the team's getting some help in that department. It won a national grant from the Lemelson-MIT program.
It was like, wow, can't believe we got this.
Joshua Schuler is the program's executive director.
The Lemelson-MIT program is a center in MIT School of Engineering. And what we're all about is inspiring young people to lead inventive, creative lives.
The goal is to encourage students to come up with solutions to real-world problems, like polluting fossil fuels.
Humans are smart. We should be able to solve a problem like fossil fuels.
Each year, the program awards grants to 16 student teams in the U.S. MIT liaison Justin Lai guides them through the process.
They submit monthly progress reports. We have a monthly video conference to go over their progress. At any point in between those milestones, any sort of questions they have.
As of our visit, the Harker team is looking pretty good, well on its way to generating power.
As heat flows through this panel, it generates electricity. And that electricity then, as we wire it up many of these panels, can be used to charge a battery or to power a device, and so on.
And so on? Don't let that deceive you. These guys are thinking big.
We're looking at a way to make actually usable deployments that we can put in aquatic environments, say a swimming pool or maybe even larger scale, a lake or the ocean, to make equivalents of solar farms that we have on land on water.
It's a way to get power that's renewable, doesn't zap the Earth's resources, or pollute the air.
It's not like, say, burning fossil fuel where you're releasing carbon dioxide. The energy is already there for you to take. It's a matter of harnessing it and capturing it.
So for the Harker Invent team, it's a race to the finish line.
The most satisfying thing is when what we plan to do works, and when everything works out perfectly. That doesn't happen very often. When it does, it just feels great.
We have a lot of great students that are going to be great leaders and are going to make a difference in the world and really are going to provide us the energy that we need 20, 30 years from now.
It's really fulfilling to see a product of your imagination, and for our whole team, the product of our collective efforts now becoming a reality.
It's a reality not just of invention, but of the challenges our planet faces when it comes to energy. And it's a challenge these young people are ready to meet.